Hi guys, it's Ms. Shamble here with your day 27 video on solving systems by elimination. I'm going to do two problems today. I'm going to do 5 and 7. So with elimination, your goal is to make one of the variables cancel out. And unfortunately, sometimes that means you have to multiply both of the equations. If you look at this one, negative 9 and 8 don't cancel, and neither do 4 and negative 6. So I'm going to have to do some multiplication. I can't make an 8 into a 9, and I can't make a 4 into a 6 by multiplying, which means that both equations are going to have to get multiplied by something. So when I look at these, 8 and 9 are bigger. I would rather work with the smaller numbers. So I'm going to focus on crossing out the y's. 4 times 6 is 24. So I'm going to make those both into 24s. That way they'll cancel out. Well, positive 24 and negative 24. So for the top one, if I want to make a 4 into a 24, I need to multiply it by 6. For the bottom one, if I want to make a negative 6 into a negative 24, I have to multiply it by 4. You'll notice I essentially just multiplied them by the other number. They already have opposite signs, so both of these numbers can be positive. So if I go over here, I want to make sure that I multiply the entire equation. 6 times negative 9x makes a negative 54x. 6 times 4y makes a positive 24y equals 6 times 4 is 24. Over here on the bottom equation, 4 times 8x makes a 32x. 4 times negative 6y makes a negative 24y equals 4 times 16 is 64. So if I look at my new system over here, you'll see that the y's have the same number but opposite signs, which means that I am good to go, because if I add the equations together vertically, these will cancel out. So I'm going to go ahead, add them together. Negative 54 plus 32 is negative 22, keep the x, equals 24 plus 64 would be 88. To get x totally by itself, I need to divide by negative 22 on both sides. And 88 divided by negative 22 is negative 4. So that's my x value. To get my y value, I'm going to take that negative 4 and I'm going to plug it in for one of the x's in either of the original equations. I'm going to do it in the first equation, though it really doesn't matter. So instead of negative 9x plus 4y is equal to 4, now that we know that x equals negative 4, I can take that negative 4 and plug it in right there. Negative 9 times negative 4 makes a positive 36. So that makes 36 plus 4y is equal to 4. If I want to get y totally by itself, I need to get rid of the 36 because it's the constant. So I'm going to subtract 36 on both sides. So I get 4y is equal to negative 32. Divide by 4, divide by 4, and I get y equals negative 8. So my final answer, x comma y, would be negative 4, negative 8. So that was number 5. Now let's talk about number 7, which I'm just going to do on the back of this on the gridded side because it really doesn't require that much work. So for number 7, we've got 5x minus 2y is equal to 14. And we've got negative 5x plus 2y is equal to negative 6. So when you look at this problem, you should notice something about the numbers, namely the fact that they match up and they already have opposite signs. So if I were to go ahead and add these equations together in the system, 5 and negative 5, those cancel. Negative 2 and positive 2, those also cancel. So what I'm left with is 0 equals 14 plus negative 6 is 8. But 0 is not actually equal to 8, which means that this is an example of a system that has no solution. If these two numbers had canceled as well and I got 0 equals 0, that would be an example of a system that has infinite solutions.